In this tutorial, I want to calculate pH of a weak acid, hydrocyanic acid, and it's HCN. As soon as you realize an acid is weak, you should realize that when it touches H2O, it dissociates only partially. So there is double arrow going and there is partial dissociation. And it's crucial in your calculations. So what you are going to produce is tiny amount of hydrogen ion and also a tiny amount of cyanide. And we are interested in hydrogen. As soon as I know how much hydrogen I have, I can take negative log of that, and that's my pH. So we are going to use ice calculation for equilibrium. Initially, they're telling me we have 1 mole per decimeter cube of HCN, this molecule, and none of hydrogen and none of cyanide. Then there is a change. We follow stoichiometry. They're 1 to 1. The good thing about acids and bases, usually, most often, you only have coefficients of 1. So this is minus X mole, a tiny quantity, and you produce exactly the same amount of X on the product side, and we put positive to re-emphasize that it's being produced. Then at equilibrium, you have 1 minus X, and you simply have X for H and Cn. Now what we need is equilibrium constant Ka, but usually in IB, pKa is rather given to you. So in order to find, it's same as pH is given. If you want H is nothing but 10 to negative pH. So Ka is nothing but 10 raised to power minus pKa. Practice this few times so this becomes second nature. So if you have pKa, find Ka by 10 to negative pKa. So 10 raised to negative 9.4. Plug it in your calculators, and you will find 3.98 times 10 to minus 10. Extremely small. And now if you remember from last segment of equilibrium, we are not going to solve equations quadratically. We want to simplify it as much as possible. But this Ka is equal to products, which is concentration of hydrogen multiplied by concentration of cyanide, divided by the reactants. The only reactant involved is hydrogen cyanide, not H2O, which is pure. So I'm going to follow the calculations here. So 3.98 times 10 to minus 10 is equal to, now notice the equilibrium concentration of hydrogen is X, cyanide is X. So it's X times X divided by, and your hydrogen cyanide is 1 take away X minus X. Now you should write your approximation or your assumption. Use words that bring this meaning across. Since Ka is very small, much smaller than 1, then you can say then you can say 1 take away X is equal to 1. 1 minus X is equal to 1. So now denominator becomes simplified. I don't need to solve quadratically. So I can say 3.98 times 10 to minus 10 is equal to X squared divided by 1. Now X is nothing but H, so let's solve for that, and then we take its negative log. X equals square root of, so 1 times this is the same number, 3.98 times 10 to minus 10. And if you take the square root of that, you will get 1.99 times 10 to minus 5. Now, X was nothing but your H, so I'm just reminding you, this is your value of H. So pH is negative log of concentration of hydrogen, which is negative log of this number, 1.99 times 10 to minus 5. And that brings 4.7 to life. So it's a very weak acid. It dissociates partially. A tiny amount of 1 becomes hydrogen, which is 2 times 10 to minus 5. When you take its pH, it's 4.7. It's getting really close to neutral, so this is a very weak acid. Now let's do a similar problem, another acid of category of weak. This time I go after benzoic acid. Sorry, the molecule is C6H5COOH. All organic acids, they end in COOH, and they are all considered to be weak acids. So this weak acid also dissociates only partially. So double arrow goes, and the very last hydrogen attached to the oxygen is the only hydrogen that you can lose. You produce benzoate, and you also produce H plus or H3O plus. Now sometimes it's difficult for students to write it, although it's given in your IB booklet. What you can do is make your life easier. Instead of benzoic acid, you can write HA as any generic acid, plus H2O dissociates partially, and it gives you A minus plus H3O plus. So these two equations are identical, and then we go after ice. To start with, initially we have 1 mole per decimeter cube of the acid, none of the A minus or benzoate, and none of hydronium. There is a change, minus X quantity goes away. Then at equilibrium it's simply 1 minus X, you have X and X. Same sort of calculation, I need Ka. Then again, pKa is always given to me, so it's 10 to negative pKa. You can stop the video at this stage and solve it, and then compare notes and see if we get the same answer. So this is 10 to minus 4.20. And when you do that, you will get 6.31 times 10 to minus 5. And this is equal to products over reactant, so it's equal to x squared over reactant 1 minus x. If you are answering IB questions, you have to write your assumption. It is 1 point in itself, usually from 4-point question. So assumption is Ka is much smaller than 1. And we can say 1 take away x is equal to 1. If that's the case, let's solve for x. Is square root of 1 times that number, which is 6.31 times 10 to minus 5. When you take the square root, and you will get 0.00794. Now x was nothing but concentration of hydrogen or hydronium. The two are the same. So pH is negative log of x or negative log of h. And we plug it into your calculators, and you will get 2.10. So calculations of the Wick is equilibrium calculation. It's ice, and that will give you answer. The last thing I want to do is just reinforce one point. It's Ka is much better measure than pH to talk about strength of acids, because it only depends on temperature. The other thing, the larger the pKa, if you're comparing two things, the smaller the Ka value. Now looking at the two questions I asked you previously, hydrogen cyanide or hydrocyanic acid has pKa of 9.4, benzoic acid has pKa of 4.7. Which one? They're both weak acids, but which one is stronger? Now if you remember, pKa of this one is smaller, so Ka should be larger. And Ka was nothing but 10 raised to negative pKa. So 10 to negative 4.7, which was 6.31 times 10 to minus 5. Therefore, you should be able to say benzoic acid is stronger. So C6H5COOH is a stronger acid compared to hydrogen cyanide. Good luck.